Directions. Read the passage and then answer the questions that follow. Satellite tagging by Rich Press. If you want to protect a species, you have to know where it is. That can be difficult in the ocean, where animals are often hidden beneath the waves. To find out where ocean animals go and the routes they take to get there, scientists attach electronic tags to them. Those tags collect data on temperature, depth, and location, then transmit their data via satellite. Jeffrey Polovina is a scientist with NOAA's Pacific Islands Fisheries Science Center in Honolulu, and he and his colleagues have tagged hundreds of loggerhead sea turtles, big-eye tuna, swordfish, and moonfish, and whale sharks. The tags allow us to see tracks in the ocean, Polovina says, but we're also interested in the bigger picture. As Polovina explains in this interview, the bigger picture comes from combining tag data with data from ocean observing satellites. That oceanographic data shows large-scale features in the ocean, such as currents, fronts, and eddies. The tracking data from the tags show how animals navigate through and around these features. Rich Press. Your research involves combining tag data with data from ocean observing satellites. What do you learn by doing this? Jeffrey Polovina. We look out on the ocean and see this homogeneous expanse, but animals see it very differently, and that's why it's useful to send fleets of animals out with tags on them. By combining tag data with oceanographic data, we get to see how animals perceive the ocean, and that provides some amazing insights. It's clear that these animals aren't just wandering randomly over the ocean. They're following well-defined paths. Sometimes they'll get into an eddy, which is a big circulation pattern that can be 100 kilometers across, and they'll ride around the edge maybe once or twice, each time taking maybe a month to go around. And then they'll get off right where they got on and continue on their way. They get pushed around by strong currents, but then they'll travel back to resume their trajectory. They're able to stay within different features of the ocean, something that for a ship would require GPS and satellite imagery. You get a sense that these animals not only know where they are, but they know where they're going in this big ocean. Rich Press. What was the biggest surprise you've had upon downloading data from an electronic tag? Jeffrey Polovina. Loggerhead sea turtles showed us a new aspect of the ocean that we didn't expect. The loggerheads we tagged nest on beaches in Japan, and they also turn up off the Baja Peninsula in Mexico. So we assumed that after hatching, they swam across the Pacific to Mexico. We tagged about 400 loggerheads, and we found that quite a number of them spent years and even decades in the open ocean far from shore, migrating back and forth along a well-defined oceanographic front. That front separates a nutrient-rich mass of water to the north from nutrient-poor waters to the south, and the turtles were moving back and forth across the boundary. People had studied these regions before, but until the turtles showed us that it was important, no one had paid attention to the boundary between them, which stretches most of the way across the Pacific Ocean. So they showed us an important feature of the ocean that we didn't know was out there. Rich Press. What was the most challenging tagging situation you've encountered? Jeffrey Polovina. Each animal has its peculiar challenges and problems. We've tagged moonfish, they're also known as opah, which are these big, slow-swimming, deep-diving animals. We were getting a lot of data from opah that showed standard dive distributions of 300 to 400 meters of depth. Then after a couple of weeks, one of the tags started showing completely different behavior. They were going deeper, the water temperature was much warmer, and the light sensors recorded total darkness. Editor's note: data from the light sensors are used to calculate location, since GPS doesn't work underwater. We thought the tag had malfunctioned and sent it back to the manufacturer, but it turned out that a shark ate the tag and maybe the opah with it. The tag was in the stomach of an endothermic shark, so it was warmer than the ambient water temperature, and of course it was totally dark. After a couple of weeks in the shark, it came out one way or the other, popped up to the surface, and we got tracks of 2 different species from the same tag. Rich Press. So the tags are also collecting information on the animal's diving behavior. What are we learning about the 3-dimensional aspect of the ocean from tagging data? Jeffrey Polovina. It seems that every time we put a tag on an animal, it's diving a lot deeper than we had previously imagined. For instance, we used to think that whale sharks mainly use the shallow surface layer of the ocean, but our tagging showed that they often dive to at least 980 meters. We don't really know how deep they're going. The tags only register up to 980 meters. They might be going a lot deeper. These deep dives are a puzzle. It may be that they're finding prey organisms at those depths. Maybe they go there to escape from predators. Or maybe they're just going down there to cool off after building up heat at the surface layer. We've also seen swordfish in the Central Pacific going down to 800 meters and feeding all day in that cold dock water, and then coming up at night to warm up. Big-eyed tuna shoot down to around 300 meters, but they only stay for an hour or two, then shoot back up to warm up and oxygenate. Different species seem to be partitioning the vertical depth structure of the ocean, each foraging on different species in a different depth range, so that they're not all at the same depth competing for the same resources. Rich Press. What's the next step for tagging research? Jeffrey Polovina. Longer lasting tags so we can collect multi-year data, and smaller tags so we can tag smaller animals. For example, longer lasting tags would allow us to analyze how the movements and habitats of equatorial tuna change between El Nino and La Nina conditions. Smaller tags would allow us to learn about movements of hatching sea turtles. Number 1. How do paragraphs 1 through 3 support the author's purpose? A. The paragraphs describe a scientist's interest in studying ocean life. B. The paragraphs introduce the scientist as well as the topic of the interview. C. The paragraphs indicate reasons why the reader may be interested in the topic. D. The paragraphs pose several questions that are answered later in the passage. Number 2. Read the sentence from paragraph 6. You get a sense that these animals not only know where they are, but they know where they're going in this big ocean. What additional quotation supports the inference that the author makes in the sentence? A. But animals see it very differently, and that's why it's useful to send fleets of animals out with tags on them. B. By combining tag data with oceanographic data, we get to see how animals perceive the ocean. C. Sometimes they'll get into an eddy, which is a big circulation pattern that can be 100 kilometers across. D. They get pushed around by strong currents, but then they'll travel back to resume their trajectory. Number 3. In the passage, Jeff Polovina states, the tags allow us to seek tracks in the ocean. Which quotation from the passage supports this statement? A. We look out on the ocean and see this homogeneous expanse. B. You get a sense that these animals not only know where they are, but they know where they're going. C. That front separates a nutrient-rich mass of water to the north from nutrient-poor waters to the south. D. Then after a couple weeks, one of the tags started showing completely different behavior. Number 4. Read the sentence from paragraph 6. They get pushed around by strong currents, but then they'll travel back to resume their trajectory. What is the meaning of the phrase to resume their trajectory as it is used in the sentence? A. To travel off course. B. To become lost in the ocean. C. To arrive at a specific location. D. To continue on the same path. Number 5. What does the author's use of the word shoot in paragraph 17 illustrate about the fish? A. It explains the different depths in which the fish forage in their search for food. B. It indicates the speed at which the fish move from one depth of the water to another. C. It shows that moving from one depth to another while looking for food is dangerous for fish. D. It demonstrates that the fish are releasing food as they move between different depths of the water. Number 6. Read the sentence from paragraph 18. Different species seem to be partitioning the vertical depth structure in the ocean, each foraging on different species in a different depth range so that they're not at all the same depth, competing for the same resources. What is the meaning of the word partitioning as it is used in the sentence? A. Defining. B. Hiding. C. Layering. D. Registering. Number 7. How does the author's use of the interview format aid in the understanding of the passage? A. It allows the author to introduce various types of sea life and talk about their habitats. B. It offers a clear understanding of the relationship between sea creatures and humans. C. It provides steps that the reader can take in order to conduct research about ocean life. D. It introduces an expert who gives examples of how animal tagging and satellite imaging lead to discoveries. Number 8. What is the author's point of view about tagging different species of ocean animals for data? A, the author disapproves of the tags because they cannot track different species effectively. B, the author approves of the tags because he believes it is important to help conserve different species. C, the author disapproves of the tags because they provide false information on the swimming patterns of different species. D, the author approves of the tags because he assists with the research and has already tagged hundreds of different species. Number 9. How does the photograph help develop an understanding of the satellite tags? A, it shows how satellite tags are attached to animals. B, it shows the effects of smaller satellite tags on smaller animals. C, it shows where satellite tags are located on the loggerhead sea turtles. D, it shows how satellite tags affect where loggerhead sea turtles migrate. Number 10, the following question has two parts. First answer part A, then answer part B. Part A, what did scientists learn after tagging loggerhead turtles on the beaches of Japan? A, there were 400 loggerhead turtles on the beach. B, most of the Pacific Ocean had never been studied. C, loggerheads migrate after hatching on Japanese beaches. D, there was an important feature of the ocean that was not known before. Part B, what effect would the information in the answer to Part A have on future scientific investigations? A, scientists will not explore that section of ocean anymore. B, scientists will decide that turtles are no longer endangered. C, scientists will look even more closely for unexpected results. D, scientists will assume all ocean animals migrate right after birth. Number 11, what is a central idea of satellite tagging? A, scientists are constantly developing new ways to study animal habits. B, scientists use satellites to create images of the ocean floor to learn about animal habitats. C, scientists tag ocean animals to analyze the causes of certain migration patterns. D, scientists utilize electronic tags and satellite images to learn how to better protect ocean species.